Okay, so for this deep dive, we are unpacking a really interesting piece of specialized hardware.
A very specialized piece.
It's the Thor Broadcast H-4ADHD-DVB-T-IPLL. And yeah, that's a mouthful.
It is.
But our mission today is to figure out how these huge places, think hospitals, universities, big corporate campuses, how they create their own private high-def TV network
Right.
using, all that old coaxial cable that's already sitting in their walls.
And this little box is pretty much the engine that makes it all happen. It's the core of their internal broadcast setup.
So it takes any video source,
Yeah.
like a camera feed or something.
Any live source, a digital signage player, that camera feed, even an old DVD player if you wanted, and it turns that feed into its own dedicated crystal clear HD channel.
That sounds like something you'd need, a whole rack of different machines for. Well, that's what's so fascinating here. This H-4ADHD, it kind of eliminates the need for all that separate gear.
Correct.
The real genius is that this one unit is, it's a multi-tool. It's acting as 4 different devices all at once.
Oh. Yeah. It's an encoder, a modulator, an IPTV server, and an ASI mux.
Yeah.
All packed into one chassis. And that integration is what simplifies everything. It cuts down the complexity, the latency, all of it.
That engineering has to start with the inputs, I imagine. You need flexibility there.
Absolutely. And you're not just stuck with, modern digital formats.
Right.
It handles 4 sources at the same time. You've got 4 HDMI inputs, plus component video, the YpPbr, for any older HD gear you might have.
And I saw a detail that really stood out that screamed professional. The separate analog input just for closed captions 608.
Exactly. That's not just a nice little feature to have. For a lot of these places, that's a legal regulatory necessity.
It really speaks to the standards they have to meet.
It does. And the quality has to be there, too. This unit gives you a ton of flexibility for encoding, beautiful HD quality, all the way up to 1080p 60.
And you can choose how to encode it.
Yep. You can use the older, really robust MPEG-2 standard, or you can switch to the much more efficient H.264 codec.
So you can tune the bandwidth.
Precisely. You can tune the bitrate anywhere from a tiny 0.5 megabit per second up to 19. It just depends on what you're sending.
Okay, so you have this pristine H.264 encoded signal. The next problem is getting it to every single screen, right? Whether that's a new smart TV or some 20-year-old monitor in a back room.
Right. And this device is built specifically to bridge that gap, to connect the legacy cable with the modern data networks.
How does it do that?
Well, for the old school codes, it uses the DVB-T standard. That's digital video broadcasting terrestrial.
Okay.
You can just think of it as the universal language for digital TV over the air in much of the world. So it speaks directly to most professional TVs without any extra boxes.
So we've established it's a multi-tool. But here's the question. Is it a compromise? Does putting RF and IP streaming in one box hurt the quality compared to, say, 2 dedicated Pro units?
That's a great question, and no, that's where the simultaneous output really shines.
Yeah.
It's not one or the other. It's pushing out the RF, DVB-T, the ASI, and the IP stream all at the same time. The signal's just duplicated. No compromise.
And for the IP side?
It uses all the heavy hitters, RTP, RTSP, UDP. And, crucially, it supports IGMP multicast.
Which is key for not crushing the network.
Exactly. You send one stream, and hundreds of receivers can just tap into it. You're not sending hundreds of individual streams.
You mentioned the ASI mux. In this kind of setup, what's that for?
An ASI mux is like a traffic cop for these digital broadcast signals. The DVB ASI input and output lets this Thor unit talk perfectly with, the really high-end, really expensive broadcast gear. It just plugs it into the whole professional ecosystem.
So how do you scale it? I mean, 4 channels is great, but a university might need dozens?
The beauty is how simple it is to expand, and that's often the most expensive part. Just stack them. You stack these units, and you daisy-chain the RF inputs and outputs together to create this bigger headend. It's totally modular.
And the signal has enough power to get across a huge campus. I see here the RF power goes up to 35 dBmV. What does that mean in practical terms?
A 35 dBmV is a very strong and very adjustable signal. It gives an installer the power they need to push a clear picture through thousands of feet of cable, all while, fighting that natural signal loss you get over distance.
So to wrap it all up for you, what this device really is, it's the critical bridge. It converts all these flexible, high-quality video sources into the specific signals you need for both old-school coax and modern IP networks. It connects the past and the present of media delivery.
But this raises a really interesting question, I think. The specs mention it supports audio codecs like Dolby AC3, MPEG-4 AAC, and critically, AC3 Dolby pass-through. What does the inclusion of those specific licensed codecs tell us about the high standards, and maybe even the legal requirements, that even these private internal video systems have to meet when they start using professional content?